So I won't steal any more time from our speakers, and we'll come back to. There's a lot of things to discuss about design and selection afterwards. So I'll turn the floor over to Cosma without further ado.
Thanks. So let's see, get this to work. Okay, everyone can hear me? Everyone is awake after the food coma. So I want to talk about issues of studying social contagion, social influence, causal inference on networks. And when I was trying to come up with a title, I suggested this one to Jennifer and said if it wasn't provocative enough, I could dial it further out. Hopefully, the fact that I ended it with a question mark rather than an exclamation mark is going to give a bit of a cue that I think there's some hope, but there's not going to be a lot. So let me start by giving you the summary first, because this is when you might actually remember what I'm saying rather than at the end. And so there are three big things I'd like you to walk away with as things which we should pretty much all agree with as far as studying social influence in networks goes. The first is that there's no question social influence exists. Okay, so we know that it happens. We know it happens for lots of things. That's not in dispute. That's not the interesting question. And the second thing which shouldn't be in dispute is that if you're just going out and doing an observational study in a social network, you are not generally going to identify social influence effects. And this is not just because it's hard to identify causal effects from observations. There are specific reasons why in networks social influence is very hard to identify, and we'll go over that. And if you want to identify it, it's not going to be done through mere technical trickery or fancier regressions. I'm taking food out of my own students' mouths by saying this, but it's not just going to come from better stats. We're going to need either special assumptions or richer data, and I'm going to try and talk about what that might look like. Now, the things which might help us are going to be richer measurements. I'm not going to say very much about that because I can't really help you with that. That needs actual science. I'm going to talk a bit about some ideas about network clustering, which might be a reason to actually go out and identify communities, as opposed to just having nicer pictures of our hairballs. There might be some way forward through elaborating mechanisms through which we think influence might happen, and there might be ways of doing this through partial identification or bounding effects, even if we can't point identify them. And so time permitting, I'll talk about all of those. And if time really permits, I might say why even experiments are hard. So the first thing we should agree with is that social influence exists, and it's important for a lot of things. And the existence proof I'd like to use is language, the fact that we are all speaking this dialect from an obscure corner of Eurasia, spoken by a bunch of Germans, conquered by Vikings, conquered by French people, conquered by the Dutch, with a lot of Latin loanwords. None of this is happening because we all somehow spontaneously decided that this was a good way of communicating. And so this is all happening through social influence. And we know it happens on much smaller scales. My neighbors in Pittsburgh speak funny. They say things like the car needs washed. Whereas my brother's neighbors in Cambridge speak funny. They said things like the car needs to be washed. And again, none of this is happening because of the influence of the different rivers we get our drinking water from or something, even though if you regressed accent on water source, you would get excellent results. This is happening because of social influence. So we know this sort of thing happens. It happens all through pieces of culture. It happens for all sorts of important things, not just how do you talk about cars, but things like how do organize an economy, or how do you make a basket. All these sorts of important things actually spread through social influence. They don't necessarily spread through just copying. There's a wonderful book by an anthropologist named Dan Sperber about all of the problems with assuming people just copy each other and just imitate each other, and what are the other ways in which people influence each other. But it's important, and it happens, and we need to understand it. And what happens when you have this sort of social influence is going to depend very strongly on the structure of the network. So Matt has worked on this. I'm going to show you a little toy example because I was raised as a physicist and that's how we think. So here is our toy model of the evolution of culture. Every person is a node. And every person makes a choice at every time point. They choose to either wear a red hat or a black hat. They choose to either vote for the red party or the black party. And this is a network which was generated from a two-block model. And you can see the two blocks because they settled down nicely. And here, initially, I've just colored everybody randomly by flipping a coin. And then they're going to follow the simplest possible process of social influence. I'm going to close my eyes and I'm going to pick a random person, and that random person is going to close their eyes and pick a random neighbor and say, I like the color of their hat. I like the color of that hat so much I'm going to copy that. I'm going to start wearing hats of that color, whatever hat I'm currently wearing, okay? So this is if you've done StatMech, we call this the voter model. If not, this is obviously a trivial, horrible caricature of all sorts of things of social influence. So what happens if you run this, again, here initially, I've just flipped a coin independently for everybody, so there should be no association between which block you're in and your choice. But you run this for 300 updates, and the east has become red. And so, half of, one community, one block has by chance tended to pick up, the red color. And then because most of your neighbors are in the same block, when you look around for somebody to copy, that's going to tend to persist. And the other block happens to have chosen the opposite color. So, if you go and you run a logistic regression of your color choice on which block you're in, ignore the error bars because they're wrong here. But you start out with basically nothing because we chose it randomly, and then you'll get an effect going one way, and you get a logistic regression coefficient of about 1.5 from this one, and then it fluctuates for a while, and then in this particular run it actually happened to switch back over. So there happened to be a spontaneous reversal of the association between these two, and then we got tired of running this. Eventually, of course, in this very simple model, everyone would settle down on the same color for their hat, and then there would be no change in the future. But you could imagine all sorts of things like adding a little bit of spontaneous noise or the occasional appearance of a new hat color and so forth. Okay? So if you're looking at something like this, all that's going on here is this very simple process of social influence, but it's giving you these weird large-scale patterns, which say now all of a sudden there's a strong association between which part of the network you're in and what color hat you wear, this choice you're making. And if you were living in this network and you didn't understand this, you would tell yourself all sorts of stories about why it is that Easterners really like red hats and what the deep meaning of red for people living in the eastern half of the network and the importance of marking themselves off from the black hats who live in the West and so forth. And you would tell some elaborate story about what happened around time step 500 to lead to this reversal. And so you might tell yourself some story which looks like this, which is the presidential vote for the U.S. in 1896, where you had one part of the country which voted for the Republicans, and then you had the South and the Mountain West, which voted for the Democrats. And by 2004, of course, it looks like this, and so everything has flipped. And you can go down to Doe Library, and you will find shelves and shelves and shelves of books explaining the deep meaning of this transformation. And I don't mean to say that they're all wrong, and this is all just some random copying process in a biased network, but unless we have a good understanding of what that sort of thing can produce, and we don't know we don't know how much of what we've seen in something like this is just social influence and diffusion on a network, and how much of this is actually something being driven by people who live in the Northeast, have different interests and values, and that's why they vote a certain way. Right? Maybe they vote a certain way because they just don't like to disagree with their neighbors. Okay. So social influence exists, it matters. The problem which makes this complicated is that homophily also exists and it matters. And so, when we go out and we decide who we're friends with, that's not usually handed to us by the great randomizer in the sky. It's not even usually assigned to us by some experimenter, unless we live in some totalitarian society like the Air Force Academy or Dartmouth, where you do have some random assignment of friends. So under conditions of totalitarianism, you can have randomized networks, but otherwise we make choices. They're not totally free. We might end up being friends with people because there's no one else for us to be friends with because all the cool kids have rejected us. But we will still have some sort of homophily, some sort of selection of the friendship ties. And those ties are going to depend on our attributes. They'll depend on things like what caste were we born into, or do we like drinking beer, or would we rather go to the gym? Do we prefer exercising over beer? And these sorts of attributes are going to have lots of impact on behaviors. If you know something about what kind of person I am, you're going to be able to say things about my behavior, about my health, even about what sort of politics I'm going to like. So we've got two things going on. One is that we know there's social influence. So if I can tell you because of social influence, if I know what your neighbors are doing, I can say something about what you're going to do. And we also know that there's selection of ties. So I can look at who your neighbors are, and that's going to tell me something about what kind of person you are. And so then, of course, you're going to do similar things because you're similar sorts of people. So I have two very different mechanisms which both lead to correlated behavior among people who are close to each other in a social network. It could be influence, or it could be selection. Both of them are going to mean that I'm predictable from what my neighbors do. And it would be nice to be able to tease these apart. I mean, as scientists, we'd just like to understand this. As people who have to go out and do things in the world, we would like to be able to know which interventions are going to be effective. If kids really in high school really do learn to smoke from each other, and there really is peer pressure for smoking, then separating the good kids from the smokers might actually achieve something. Or you might want to target the kids who are sitting out back behind the gym and convince them that they really don't want to smoke. Because if you can get some of those as influentials, it's going to have this impact on the others. If, on the other hand, the reason all of the smokers hang out together is that they're the ones who are already feeling alienated from high school, and that's why they want to do that sort of thing, and they'd be just as likely to smoke anyway, even if they didn't have other smoking friends to hang out with, then that sort of intervention is not going to be very useful. You need to target people individually. And again, this isn't just for things like, can you keep kids from smoking? It's also for things like, can you get people to go out to vote? Or can you get people to go out and buy a totally superfluous electronic gadget because their friends are buying it? And so on and so forth. Okay? So these are things which would have a lot of consequences if we can tease these two things apart. And this is a causal inference question. It's not just a regression question. It's not just a conditional probability question. We really do want to know what happens if we take somebody and influence them. If we manipulate them, what's going to happen to their friends? And so, how could we begin to do this from observational data? There's basically three main ways you can get causal identification. The first one, which we pound into their heads in baby stats, is that you could do controls. So you could say, look, I'm going to find the right set of control variables, I'm going to find the right set of covariates, and I'm going to condition on them. So, with modern techniques, you can actually explain what it means to have the right set of control variables. You want to find variables that block the indirect pathways from the cause to the effect. And you don't want to block the direct pathways. You don't want to condition on the stuff which leads from the cause to the effect. And you also don't want to condition on things which create indirect pathways which wouldn't ordinarily be there. So this is what Judea Pearl, in a perhaps unfortunate phrase, called the backdoor criterion. You want to close all of the backdoor paths from the cause to the effect. The second thing you can do, especially if you're an economist, is you look for an instrument. And so you could say, look, I'm going to find something, some source of variation in the cause, which is just totally independent of everything else, and I'm going to see how that source of variation in the cause, if that variation in the cause is associated with the effect, the only way that can happen is if I'm wiggling the cause somehow, and the cause has to then channel it to the effect, and so then I've got a pretty convincing case. And the third thing you can do is you can try and find some sort of mechanism. You can say, look, I have some understanding of how this cause would really do things to the effect variable I'm interested in, and I can measure each step along that chain, and so then I can actually identify the causal effects. Even if I can't control for everything, even if I don't have independent variation in the cause. So this is what Pearl calls the front door criterion. So let me just explain this control idea. This is a set of pictures we probably ought to inflict in baby stats, but for some reason we don't. I have a student, Joey. Joey wants to go to graduate school. Joey wants to know if studying for the GRE is actually going to get him into a better program. So Joey goes out and collects data. And Joey sees that there is indeed a correlation between his students' GRE scores and the rank of the graduate program they get into. And before Joey can conclude anything about how much would improving his GRE score do for him, he really ought to control for some things. And so, one of the things he ought to control for is that students who spend more time studying as undergrads are probably going to also therefore score higher on the GRE, but they're going to get into a better graduate program for independent reasons, like they'll have better grades and they'll have nicer letters from their teachers and so forth. So, in this case, we have a common cause of the two variables. We ought to control for the common cause. Right? So far, so good. The problem is when we control for common effects. So Joey has a friend, Irene, and Irene would like to go off to Hollywood and become an actress. And Irene, being a CMU student, goes out and collects data before she takes this plunge. And so she goes and she looks at, she wants to know, for instance, when she looks at actors, is there some association between their looks and their acting ability? And because she's an econ stats student at CMU, she knows that people respond to incentives. And so she thinks that probably actors who are better looking don't practice as much, and so there should be a negative association between looks and acting ability. And so she goes out and she collects data where she looks at, she gets data on lots of actors and has people rate their looks online, and she has people look at clips of them and rate how good an actor they are. But she doesn't have unlimited time, so she just takes the 1,000 top actors according to their IMDb entries. Okay? So she selects actors who are successful. She only looks at actors who are above some threshold level of success, and then she's going to find that negative relationship even if they're totally independent. She's going to be she's controlling or selecting on a common effect, and that creates a conditional association between the two parent variables. So, this is here it's a pure selection effect. You would get the same thing if you were controlling for this. If you regressed acting ability on looks, controlling for success as an actor, you would get the same sort of effect. So, when you control for a common effect, you are creating an indirect pathway which links these two things. If you are just a medium successful actor, there's going to be a negative association between your looks and your acting ability, because you're probably not much better, not outstandingly successful in either one, right? If you're just a medium successful actor. So this is what we want to avoid. We want to find the causal effect, the common causes, and control for them, but we want to avoid conditioning or selecting on common effects. And now it's totally trivial to understand why we can't identify social influence from observations. This is the causal diagram. We want to look at Irene's behavior tomorrow, and we want to know, is it caused by Joey's behavior today? Okay? This is what we would like to identify. Now, there's only going to be that causal link if Irene and Joey are friends. Why would they be friends? Well, that's going to depend on their latent traits. Okay? They're going to have various traits on which they're homophilous. Maybe these are things like caste. Maybe there are other attributes. Maybe they're things like, do they like to go to the bar every day at happy hour? Or do they meet because they go to the gym because they're both training for triathlons? All sorts of things like this are going to go into, are they friends? But I look at Joey's behavior today, and that tells me something about what kind of person Joey is. It tells me something about their traits. Knowing that Joey and Irene are friends, I can deduce something about Irene's traits. And then, of course, I can predict something about Irene's behavior tomorrow. Okay? So I'm selecting the people I regress on. I select them so that they are, in fact, related to each other, so that Joey and Irene are similar. And then even if those edges, those arrows, those causal pathways aren't there at all, even if there's no social influence whatsoever, I'm going to have predictability from Joey's behavior today to Irene's behavior tomorrow. So this is the problem. Now, you can make the same argument with all the algebraic symbols and some theorems. I'm not going to give us that, and partly in the interest of time, partly because it doesn't really add anything to the essentials. The real issue is that we have this endogenous baked-in selection bias. The network ties are endogenous. They're formed as part of the same process which generates the behaviors we're interested in. And that means that which people are available as regressors, as predictors for my behavior, for ego's behavior, is informative about what kind of person ego is. And so there's endogenous selection bias, and it's just not going to go away. There's basically nothing you can stick into that graphical model, that path diagram, where you can condition on it that's going to block that indirect backdoor pathway. Now, people don't like this conclusion, so there are a bunch of things that they would like to see claim would get rid of it. One is controlling for prior history. That doesn't work. One is looking at changing network ties, so seeing whether seeing if things alter when ties form and disappear. That doesn't work. One is propensity score matching, because who doesn't love a good propensity score? That unfortunately doesn't work. One which is a lot cleverer and was a lot harder to understand why it doesn't work is asymmetric ties, where you have a directed graph and the ties are asymmetric. That also doesn't work. So how am I doing on time, Matt?
7 minutes.
Okay. Very briefly, the idea with conditioning on history is this. I'm going to look at not just behavior today and tomorrow for Joey and Irene. I'm also going to look at Joey's behavior yesterday and Irene's behavior yesterday, and I'm going to throw those in as control variables. Okay, so this is an obvious sort of thing, but again, as soon as you draw the diagram, it's obvious why it doesn't work. Because it doesn't block that backdoor pathway where we look at what Joey did today, we learn something about Joey, and then we learn something about Irene. Okay. Arun.
So obviously just only under the assumptions of the styles of diagrams you're drawing, but if I added, I don't know, Matt, and I chained Matt as Irene's...
Hold that thought. Okay. So that diagram was a bit of a mess. Obviously I've got all these extra arrows going along. If I wanted to allow the social network tie between them to fluctuate, it looks more and more like a plate of spaghetti. But you can actually trace everything through. And even if you include lag values of behavior or lag values of the social tie, it doesn't eliminate the confounding. It doesn't give you identification. And it can actually make the identification worse, the bias worse. And the reason is that these extra time points you're including also carry information about the latent attributes. If those are redundant, if these are all redundant and giving us similar information about the attributes, then we're reducing the bias. And maybe asymptotically you would reduce it to 0 if you had infinite histories. But if they're giving us non-redundant information, then we can actually increase the confounding. And in general, it's I won't say whether it's going to go one way or the other. It's just not going to eliminate the problem. Okay. Propensity scores are a cute trick. We look at some covariates, we figure out what's the probability that there's a tie between Irene and Joey, and then whether there's actually a tie is only depends on the propensity score. It's in the attributes are irrelevant, but this is true whether it blocks the indirect pathways or not. Okay, so this is true whether we've got identification or not. And so there's some very cute papers where people take real experiments and say, what conclusions would you reach if you just did propensity score matching on observational variables in these situations where we know the experimental truth. And you can conclude things like calling people up and reading them a message saying it's very important to wear your seatbelt all the time causes them to go vote. Okay? And I will leave you to ponder why you would conclude that if you just did matched controls, or you can track down the paper and spoil it for yourself. Okay. So the asymmetry one is very clever, and worth a little thought. So I look at edges which aren't reciprocated. And so this is this high school tragedy where you go to Irene and Irene says Joey is your friend and Joey pretends not to know who Irene is. And so you do a regression of Irene on Joey and you get one answer, and you do a regression of Joey on Irene and you get a different answer. And this could be due to influence. If people pay more attention to those they're going to claim are friends, then that would be fine. But you can also get it without influence. So we came up with this very complicated story where there's homophily, but there's also a preference for some values of the latent trait. And then seeing that the edge is unreciprocated tells you that Irene has a less desirable value of the latent trait. Russ Lyons had realized that all you need is a non-uniform distribution of the latent trait and asymmetry. Then it's just telling you the unreciprocated, the person who's sending the tie but not receiving it is in a low density part of the space. And in either case, since you're learning something about the latent variables, you can predict something about their behavior. So this is really just Bayes' rule. Symmetric prior, anti-symmetric data, you get an anti-symmetric posterior. Nothing to it. You could hope that there are parametric models. We don't know of any. We bashed our heads against the linear Gaussian case for months. It doesn't seem to work. So what about instruments? This is Arun's question. So we want to find some variable which is going to predict what Joey does, which is going to affect what Joey does, and see if we can use that to predict Irene. Right? And the important thing is that the instrument can only affect Joey. If the instrument has any other pathway through which it tells us about Irene, then it's not a good instrument. So we need to block all the other pathways. And so what people like to suggest is using a friend of a friend. So we introduce Carl, who is a friend of Joey but not of Irene. And so you want to look at this nice blue pathway where you look at what Carl did, and then you use that to predict Joey, and then you use Joey to predict Irene. And if that should only happen if there is in fact social influence. But knowing something about Carl and the fact that Carl and Joey are friends tells you something about Joey. And knowing something about Joey and the fact that Joey and Irene are friends tells you something about Irene. So you have this unblocked backdoor pathway, and it's not a valid instrument. Okay. Now, I don't want to say there are no valid instruments. Again, if you're running a totalitarian enterprise like Facebook, you could introduce lots of instruments, but friends of friends certainly aren't one. So this is all the negative stuff. So we can identify things. It would be wonderful. We know it exists. We can identify it from observation. And this isn't an issue of the data being too small. You can have your data be as large as you like, sitting on as many distributed machines as you like, and it's not going to help. I was going to say something about measurement. I don't have time to say something about measurement. I will say something about clustering because this has come up a lot. The fundamental problem here is that we have this X variable, these latent attributes, and they're latent. We can't measure them. So it would be nice if we could somehow get away from that and somehow see what they are. We're not going to be able to really measure them properly in a real measurement sense, but maybe we can proxy them. So if you believe that the network forms through homophily, then you're going to tend to resemble your neighbors. And this is going to be very pronounced if you have lots of neighbors in common, like if there are lots of triangles. And so those people are also going to tend to have lots of neighbors in common with you and so forth. So if you believe in latent homophily, your network should break up into modules or communities. And so you should then be able to reverse that. You should say, well, look, I found my clusters. And I don't know what this X variable is, but I know that somehow it's showing up in these communities. So, if you can convince yourself that the estimated communities were a sufficient statistic for X, for the latent attributes, then you would just throw those in as control variables in your regression and you'd be done. So we currently have no idea when that holds. We don't know how to make this work for a block model which isn't pure homophily. We don't know what would happen if the right block model was not pure homophily, but you used pure homophily anyway, whether it might not be bias amplifying, and so on and so forth. So I have a student who's working on this now, and hopefully she will have some results by spring when she has to leave and grow up and become a real girl. This is, I think, a promising approach. Where we try and use the rest of the graph to figure out at least a proxy for the latent attribute, which goes beyond these dyads we're looking at, and it might actually give us a reason to do community discovery as opposed to just having pictures and theorems. Mechanisms would be nice. It's too hard to measure them, and I think I'm out of time. Am I not? All right. So I will just leave this up for this idea of partial identification. There may be situations where even if we can't point to identify things, we could put non-trivial bounds on it. And there are now some papers which do this under extremely strong assumptions. This again seems like a promising approach, but but it's all very new, and the assumptions are currently too strong for industrial use. Okay, thanks very much for your attention. Sorry for running over.